All right.
I like those.
Yeah, sorry. Okay, go.
All right. Hello again, Matthew.
Hey, Ryan, how you doing, man?
I'm doing well. You're joining us from Microsoft Office, I see.
Yeah, I know. I can draw here on the board. I know
All right.
my head or the board.
Yeah, we're getting old, aren't we?
Oh, I guess that's a good way of saying it.
Yeah. So ready for another episode of Cloud Simplified?
Let's do it.
All right. So, Louis, welcome to the show.
Thank you.
Yeah. So I understand that you want to talk to us a bit today about some of the things that we can do with Azure and the cloud about not requiring servers to be able to solve all the world's problems.
No, that's crazy.
Perhaps not requiring servers, as in not requiring you to configure them. There's lots.
That's correct. Well, yeah, that's correct. We make them very transparent or nearly invisible. So yeah.
Yeah. I wish I made enough money as the guy who obviously came up with the word serverless, which obviously is.
That's kind of an oxymoron. Yeah. Yeah, for sure. So why don't you go ahead and give a little introduction to yourself as well? Because I understand you also have a podcast that you have where you talk about some of the cloud topics and so forth.
Yep, absolutely. So my name is Louis Berman. I'm a cloud solutions architect working for Microsoft. What that means is that I help some of our largest companies do very large and or interesting things in the cloud. So I have personally fielded, I guess this is in 2016, but it's not been much surpassed, the largest HPC cluster ever done in the cloud. That's like, thousands of cores, all in one memory set doing stuff. I've done lots of small things too and everything in between. I created the very first Azure CDN before Azure created the first CDN about 2 years later. And so I've been puttering about it. And, I'm supposed to say that all sorts of things, Azure's wonderful and everything, but it's really important to know I don't really understand how to do programming any longer without the cloud, right? So I used to have all these great skills. I could do things on desks. I could work with languages like C++. I could, do all sort of arcane networking things and some
the Win32 API and
we built data centers. I mean, like millions and millions and millions of dollars building data centers. All that is for naught. I don't know anything. So It turns out though that if you want to do modern development and you want to get an incredible amount of code done in a very short period of time, and you want to de-risk your entire organization and process, then Azure's the way to do it. And, I'm paid to say I love Azure, but the truth of it is I love Azure. So.
As do Matthew and I. That's for sure.
I was going to say, what else are you doing this week?
So, I feel a little stupid about it, but we were talking about this the other week. We don't really do on modern apps any longer. At least I don't. And so you used to have all these tricks and you used to conceive of things in an on-modern sense. And I think that's what I want to talk about today. So there's a company who, excuse me?
As I said, there used to be lots of plumbing you had to build, to be able to allow your applications to communicate, the different layers and tiers. We had WCF and, and SOAP and all these different mechanisms. And today you can just, build a function and put it out there, not have to worry about scaling, very, very easily, communicate with said function with a web app. Actually, you can have a web app, not even really run on a server per se. It's like a static, single page application that just calls your functions. So yeah, things have evolved, significantly to allow that developer to build something that delivers business value quickly.
Absolutely. I'll give a bit of scale on how Azure is compared to what it used to be. So I used to own a company called Braintree, and we made software for selling shareware and other software over the net called Money Pump. Okay. And we spent I guess starting in 97 to 99, we had a team of 6 people who put 2 entire man years apiece. So that's 12 man years to work on a product basically opened a couple of dialogues, transferred back and forth, order to make it happen, enabled through encryption the use of the program. But mostly it was incredible amounts of glue. And, I'm sure you guys have had this thing. You have, at one point in your life, there's some piece of code that's the most important, interesting thing you own. So I had 4 or 5 CDs at the time. These are CDs, not even DVDs. Right. I had them in a safe deposit box. They were the latest and greatest. This is when we weren't doing a lot of source control.
That was your offsite backup?
Oh my God, yes. Exactly. So the point was, years go by, and somewhere in it must be 2015, I'm looking in a closet, and it turns out I have those CDs. They had been transferred. We closed that account when we moved, and the most important thing I had, and the work of 6 guys working for 2 years, was in the closet. This happened to be on a Friday. So I got in my head, I know how to do modern development. And so I went ahead, and I didn't do like the entire thing in one weekend, it wasn't that, but there was a bunch of client server code. There was like 10 or 15 of the big pieces were client server sort of things. And I just, in a couple of hours, I wrote the equivalent of it. It's like nothing. So the story I want to tell you today is a modern story in that ilk, right? So there's a company in Boston. I won't give you their name, but they manage, home healthcare workers, and they do it for the entire country. And they want to have information, what they did, who they did it, what have you. And they decided they wanted to be a modern dev Azure shop, and they wanted to go all serverless. But serverless in their sense meant, how can I say this? I guess I would think of serverless as the serverless are components of an app. They're part of the stuff that pulls the solution together, but it's not the app itself, right? It's construction kit. They took it from the view that it's serverless, and oh yeah, by the way, here's what we want to do. So that was already not a very good thing. And then they decided logic apps was the way to go. And I don't mean logic apps and what I would consider the normal use of logic apps, which is to do connectors and glue and send off emails and receive information from SAP or put things together. They wanted to create an orchestrator based on logic apps. And in their world, they received more than 1 million records a day that they had to munge around and do processing on. So it's 1 million records in an XML file, do processing, fan out, do some stuff, ultimately fan back in and go forward. So they tried to do this purely in logic apps, and they had a team of people, a dozen people working for months, and it didn't work. It worked a little bit, it worked on little bits of data, but it couldn't scale, and they didn't understand why it was. And so I naturally, I'm an architect. I know how to do everything. And so I went ahead and told them how to do it better, or at least what I thought was better, or at least some explorations of how to do it better. And this, as you can imagine, that didn't turn out well. They just wanted their solution to work. So it turns out, and the reason I say Boston is because I live in Philadelphia. And so I had a 5-hour train ride from Boston, Philadelphia. And I was like, they didn't listen to me. Maybe I could show it to them. So let me show it to you instead. And let's see if I can actually share my screen.
All right, Louis. So I have to give you some props to the name of this, because that's Fun City Doodah.
No, it's Fun City Doodah. Actually, I never realized that. It was supposed to be funkity. Like get down, get funkity.
Oh, okay.
But I like Fun City better, and I think I'm going to change that. That's even hilariouser. So I tried to have stupid fun names for every one of my products. So anyway, I'm going to show you Funkity Doodah. Funkity Doodah was to show this company how they could work in a more modern dev sort of sense using Azure functions and durable tasks, and quite frankly, just knowledge of how to work in an Azure friendly sort of sense. So
taking a really super quick step back, but we don't have to go into great detail about logic apps and functions and so forth. But we mentioned a couple things already. Logic apps is kind of more of the orchestrator type mechanism we have in Azure to wire up I like to think of it as kind of a patch panel service. You know, you have input coming here, you want to wire it up to output over here, maybe do some stuff in the middle. That
That's
stuff,
great.
yeah,
That's right.
that stuff could be a function, you know, that might do interesting things with that data, you know, or use something native, you know, within the Logic App service. And a function takes that a step farther where you can actually deploy code to do very customized things. And
Yep.
you mentioned one third thing, the durable functions, which is, you know, typically, you know, going back to that funny word serverless, you know, at the end of the day, it runs on a server. But when you have a serverless application, it tends to want to be stateless, where you don't, you know, where you're not able to maintain state across calls or be able to have something maybe asynchronously running that returns back, you know, hey, I'm 20% done and 50% done and so forth. Durable functions provides you a way to maintain state, you know,
Yep.
across calls. So just kind of outlining those
Yeah.
three little scenarios.
I'm trying to find a lovely web page, and I don't see one that shows us. So I'll just
Okay.
walk you through it.
Yeah, we'll put that in the show notes. I just wanted to
Yeah.
kind of quickly kind of walk through those three things that we mentioned. So, okay.
Exactly.
Yeah.
So you have to step back, right? It is, we used to write small little programs, and they worked with our modicum of data, and then we were done. There's a big difference between running a piece of code on 200, 300, 400 pieces of data and running it on 2 million, 5 million, 10 million, 100 million, and more. And while, you know, all of your listeners undoubtedly will not be working at that scale, I'd be very surprised if there weren't several of them. And so you really need to think about the cloud in a very, very, very different way. So funkity doodah, you know, basically the purpose of this is to take a really large XML file, break it up, and then do work on the stuff individually. That's what's called a fan out. When you look at the durable tasks link, you'll see there's a diagram. You're taking one job, fan it out into tens, hundreds, thousands of jobs, and then ultimately fan it back in. In other words, collect statistics or maybe final work result from all of those things. So the Logic app design this company did worked great on XML files that had hundreds, maybe 1,000 items. But when you went into hundreds of thousands and millions of items, it just fell apart, because ultimately Logic apps, in an orchestration sense, are not meant to orchestrate really, really big processes. They're meant to be building blocks of other things, whereas functions work at this stuff perfectly. So we have a bunch of different...
And XML's biggest benefit of being self-describing is its worst enemy in terms of getting exactly bloated very quickly if you have a lot of data. So interesting.
Yep. It's really important to understand that the XML wasn't there. It's something upstream. You might have substituted JSON as an example. You might have substituted pointers in JSON that then pointed to other data somewhere asynchronously, which would help scaling. But in either case, the durable task library works great for this. So we have a tool, a back end that is going to take this data once it's processed and ultimately put it in a Cosmos DB. And then we have a worker which is going to do all of the orchestration. That is an Azure function. We have a couple of helper libraries, the Cosmos library just to talk to Cosmos, some common helper classes. And then I like to, when I do communication stuff, to use Postman to kick things off. But if the thing you need to kick off is relatively complex, I tend to write my own program to do it. So kickoff will do this. And we're going to look at all this stuff. And then finally, I didn't have access to their data on the train. So I just grabbed a comparable data set from the Common Core of Data XML format. It's just a bunch of data about schools. And the data in this case didn't matter. It was the pattern that sort of mattered. So let's look at the actual program itself, right? And let me switch classes. I have to stare a little bit more. I don't see my face, so hopefully I'm not obscuring myself in the video camera, right? So here was the raw data, just bunch of CSV sort of stuff that I got. And, this was gig. size, whatever the case may be. And then what I'm going to do is I have my kickoff program, which is going to ultimately just make sure that the files and the URI work, and then it's going to upload a blob of the actual data to be worked on once it parses it. That's the schools, that XML file that I am creating.
Okay, so you're just taking this comma separated data, converting it to XML, uploading it to blob storage just for the sake of mimicking your customer scenario of having lots of data in an XML file. Okay, got it. Okay.
And then it literally kicks off a message to the Azure function. And I've created an Azure function. We'll look at this in detail. But basically, this is an orchestrator. The orchestrator says, hey, get me a message, kick a process off, do some stuff, fanned out. This thing jobs could be literally millions, which it got from another process, and then collate the stuff together. In this case, we're putting together a report, our own report that says what happened and how it goes. And I'm looking at 150 lines of code. So I'm sure I haven't counted in this, but I'd be very surprised to find out that all this code was more than 1,000 lines of code. Very approachable. The sort of thing that once you know how to get started on the thing, you can get going. So let's just run this to see what it is. So it's real important from a startup project perspective we want to have the Azure function. I called it worker kicking off. And the Azure function is talking to a backend, which is just a control, an ASP.NET Core app with a controller. And that mimicked their environment. Some other program was the actual controller to receive this stuff. So if I'm going to run this thing, I'm going to just run both of those. Give it a second to kick off. By the way, I'm using Visual Studio 2019. Today is literally the very first day. So I did run this, but if the demo gods are going to treat me fairly. Oh, something really important just happened. So when I was running this last, I actually went ahead and was trying to break it. And so I basically deleted things. I had processes that didn't finish. It's throwing errors right now. So let's go through here. I don't remember exactly where I was going, but the whole purpose of the durable task library is to do a few things. It is to coordinate all the various pieces of action that you want done in an overall project. That's the first thing. The second thing is it is designed to be durable. It is retrying stuff. So in this case, it is failing on retrying stuff. That's because I left it in indeterminate state. And ultimately, for each of these records, I forget how many I was doing, it is trying to parse them, recognize them, and ultimately call web service on the back end. So we'll let this stuff go, and I apologize that I didn't clear this out beforehand. I'm just going to take a quick look at Azure Cosmos DB, and I'm running this stuff on a local emulator, although by no means does it have to be in an emulator. These are just records that are ultimately parsed along, and
so that's an interesting thing about Azure Functions is that you don't actually need. You can test them locally. You can run these on our edge devices or IoT edge. You can run them on premises. You can run them on Azure Stack. You can run them with our on premises solution for kind of mimicking some aspects of Azure on prem, and then you can also run it as you're doing right now in an emulator on your PC locally. So
So I'm going to, and I apologize for this, I'm actually just deleting the files in storage. This is also running on a local emulator. And the reason why I'm doing this is because I've left it in indeterminate testing state. And while I could definitely fix this, by going through all the levels, it would just take a fair amount of time. So we're starting, we have no blobs, no anything. we're going to then, I'm going to go here and I'm going to actually delete the collection. And this was, hold on a second, that was the schools collection.
Mm-hmm.
And then this will basically flatline me in my world. And then the last thing I need to do was, we had blobs. You may have noticed I need to create a blob container. Funkity doodah. I think that is correctly spelled. And the reason why I am doing that is only because there is a bug that was not creating that directly. So let's see if the demo gods are going to be with me again. And let me just real quickly make sure everything is exactly as I expected. So the worker and the back end are starting up. I am talking. This key turns out to be a magic key that's talking to the emulator for Cosmos, but could easily talk into the cloud. And then I have a thing called local settings, which I'm using development storage, but that could easily be blob storage in the cloud. I'm only doing 100 jobs for this demo, but that I think it's either 0 or -1 means do however many jobs you want. And then I'm talking ultimately to my what we call it, to my back end control.
So that would be your function basically that you're that you're communicating with.
Yep.
Yeah. Okay.
And of course, because everything is going to be like that, it just failed because I locked the file. I hope you're having fun and making fun of me as I am going through all the normal stuff that happens. I originally was going to do this on my laptop, which had both 2017 and 2019, but today is just one of those days. So
we'll just blame him.
It's definitely Ryan's fault. Ryan had communication problems getting up and going, but the reality is, it is. Oh my God!
Some people.
So I have a locked file. So I'm going to have to wait for that locked file to unlock, or I will literally have to reboot. So
do you have the function emulator running in the background? Maybe it's still.
Yeah, I'm going to, let me close down storage. Let me close down. This is for those of you out in the audience who are looking at what happens. It turns out that development of all type is relatively difficult, even when of course, it is running and doing what it's supposed to do. And the problem with this stuff, of course, is that I went ahead and, tried to get this stuff tested before I did it in front of you. And so, of course, I'm being punished for that. We'll give it one more go. Usually I do this when I have a room of 50 or 60 people.
So, there's the pressure there.
Yeah, so this is a little bit of a treat. And great. So you see I get a file load exception. Mm-hmm. It is literally, you know what? I have an idea. Let's go ahead. This is the beauty of source control. And, I'm going to pretend that I did this on purpose. So if we go to repos, I'm at dev.azure.com, Azure how to /funkitydoodah, FUNCITYDODA. And this is the project which you can download. I'm going to repos and files, and then I'm going to do a clone. And I'll clone this onto Visual Studio and just make sure that I am, I'm good to go. Feel free, of course, to edit this and say silly things about me in the background.
Get her done.
It's always like one of those things you hear an album where, there's this big setup to people that you're supposed to, clap or do stuff. And the guy invariably always says, and don't keep it in the recording. And then, of course, they do keep it in this recording.
Yeah, we'll probably make the recording.
So I'm waiting down to clone this. So anyway, what we're going to show ultimately is that the thing works. and that the thing resumes. And I want to walk you through the actual code of how it goes. So here I am. I'm going to clone from the funky-doo-dah repository, and I'm going to just clone it onto the desktop with a different name. And the reason why we're doing this is we had basically a locked DLL, and this is purely a dev time issue. And you'll find sometimes when you're doing function development or web jobs development, which is very similar to it, if you crash out as opposed to close out of your instance, you can leave open file handles. And you'd say to yourself, hey, why don't they make that not happen? But it turns out that in a function sort of sense, it's a little hard to be deterministic like that. It is because everything is effectively free threads doing their own thing.
I love it. It's like not only is this cloud simplified, this is like dev simplified.
I hope it is dev simplified.
I think it is.
Okay, so I'm going to open the project and solution. I just created on the desktop funky-doo-dah 2.
I keep wanting to sing Zippity Doodah in my head. I'm going to freak, you're giving me an earworm that'll last all day.
On the repository, we can rename it. Zippity Doodah is a perfectly fine name. So I have a long history of doing this sort of stuff. Stupid names for stupid things. So back in the day, we made a lot of money with a product called Money Pump. And the reason we named it Money Pump is because it pumped money. It made us money. And we were thrilled to have that. And so I think this is the exact same sort of thing. So rebuild all failed for some reason.
If you ever have a need for another job, I think marketing might be your calling.
I am still getting the system file load. It's actually a dependency. It's not my file. It is some other file. So, gentlemen, how do you think I should proceed? I can walk through this, but it'd be really great to show it.
Yeah, let's just walk through it.
Okay. I'm sorry, dear listener. I am sorry. Trust me, it works.
All your bases belong to us now.
Yes. Okay. So we're going to start through the various projects, and firstly,
do you have this deployed by chance into your subscription?
No, I do not have it
deployed.
Okay. 4 or 5 months ago and forgot about until you said, hey, let's do a thing.
Okay.
So the very most important thing, and I would encourage anyone to do something similar, is if you have a product that you want to share with people as source, it pays to have a license header in all the files. And there's this tool called license header. And if you look at any one of my source files, you will see that I have a license in all my code. And I try very hard to make sure that, of course, I make everything open source. So let's look at the code. We have a controller, and its entire job is to go ahead and write a record, the school record in this case, which is coming over the wire, and just has a few fields. Imagine this is the extracted info from XML file. And the idea is to write that into Cosmos. And then very, very importantly, you return a status code. And the reason why this is a status code is important is because remember we were talking about fanning out, in other words, taking a collection of work and doing them individually, hundreds, thousands, maybe millions of threads, and then ultimately bringing all the results back together, fanning in. Well, it turns out that is a particularly difficult thing to do. But if you use the durable task library, it's particularly easy. So the back end, you can just think of it as a web service. It's purely there to generate load. Let's go the other direction and look at the worker. The worker has a function, which is funky-doo-dah orchestrator. The physical file name and the function, or actually even the actual name of the method, don't have to be the same. But funky doodah orchestrator is the thing that's ultimately going to surface into Azure Functions. I get some configuration information. And very importantly, I'm going to have the maximum number of jobs to do in any shot. And that's purely for testing purposes only. If I had 1 million jobs, I should do 1 million jobs. And then I have my back-end URI for that web service, the back-end web service we looked at. So then I just get the name of the blob, just using a helper method, it's being pumped in to the orchestrator. And then I use a function called funky doodah get process school jobs. I realize that's a little verbose, but this is the thing that is going to fan and get the jobs themselves. And there's a really important thing when you're doing durable tasks. This special orchestrator function, the function that has the durable orchestration context, cannot have any multi-threaded stuff in it intrinsically. It can only do this await task when all. So, but we're going ahead and we're getting all these jobs, which, has an await in it. It's literally downloading the file, putting it into a stream, and then it's enumerating through that stream to create jobs, which are a chunk of data that's ultimately going to say what you're going to do, what you're going to create, how it's going to be broken into little pieces.
So if this is going through all the lines and basically invoking your function that actually does the work. So,
well, not invoking. Yeah. It'd be better to say it's preparing to invoke. Because you're going to end up here, if you had 1 million pieces of things to work on, the jobs collection, the list of jobs, would ultimately be 1 million things. Then it comes back over here, right? You've just called an orchestrated function. And the reason why we do this as an orchestrated function is, let's say in the middle of getting those hundreds, thousands, millions of jobs to process, you fail. Well, the durable task library knows how to resume. So you'll see constructs when you're doing durable tasks for intrinsic resumption. So even a baseline Azure function that has a blob trigger, if you get triggered by a blob's existence somewhere and you do something and you fail, it will try it 5 times by default over. And if that still fails, then it will take the original message that was kicking off the blob trigger and put it into a poison message queue for further processing. And it's really important that when you're creating robust, highly performant applications that you can scale out across multiple machines, that you figure out how to resume no matter what happens. So basically, I get all these jobs, and then I have a very simple task that is going to process individual jobs. And notice that all it's doing is adding the tasks together. It's not kicking the stuff off yet, right? But it's calling an activity. An activity is something that can resume. Let's say it had 1,000 to do, and it blew up on 501. It would do the next 499 the next time through. And you'll notice there's no special code in here that says, hey, am I resuming or anything? How do I handle when things fall apart? That's another reason why the durable task library is so great. So if we look for the process school job, I think that's just a very simple thing. In this case, I'm basically getting, the call that's going to that back end, right? I'm just calling, the back end. By the way, I don't know if any of you guys are familiar with a library called Fluent URL, but I am taking the URI, the absolute URI about it, which is a string. I'm appending 2 paths, /API/segment, and then I'm posting JSON to it. FLURL is a really, really great library for you to use. It makes programming HTTP calls incredibly, incredibly easy. So the whole reason this thing exists as an activity is something, it's being triggered. It does something. In this case, it's calling a backend, and then it gets the status code and it returns it in a durable way. That status code is the entire reason why we are using durable tasks as opposed to just stuffing a queue ourselves and running the thing off the queue going forward. So now if we go back, excuse me?
I said, okay, yeah, I'm just walking through.
Yep. So now we've basically staged all of the tasks to go. And then we have a very simple asynchronous task when all. It runs all the tasks. So if you have, 8 cores, it's going to run them 8 at a time. It's going to be very flexible depending upon the changing availability of processing power on your system. You need to know heavy duty processing at all, which is really great, right? It is, again, we like to get as much of the generic code out of our code and concentrate on the value. So I've written orchestrators like this to do what task when all on those tasks would be, and I've written them to 100,000 lines of code level. That is at the level this is. It is really amazing sort of magic. And then once I'm done with all the tasks, all I do is iterate through the results of the individual tasks, which were the instantiation of the jobs that run, and I create a report, and I pass the report back. That's it. It's super, super, super simple. I'm sorry. There's one more thing. And remember when we had the kickoff, which kicked the thing off literally?
Mm-hmm.
I have an HTTP start function, which takes a durable orchestration client. That's the starter. And basically it reads a string that I threw over HTTP. And then it kicks the orchestration off. It starts funky doodah orchestration.
So if you compare this to running this all in a sequential type manner, like have you compared and contrasted what the baseline performance would be to kind of do this fan?
There's lots of different ways to compare it. So firstly, it is incredibly faster in the sense that it can fan out not only onto multiple cores on a given machine, but this is designed to fan out to multiple cores against hundreds, thousands, tens of thousands of machines in some cases, right? So same coding model, whether you're just using a bigger machine and using more of it, or whether you're using tens, hundreds, thousands of machines. So that's the first level. The second is, on one level, it's always, if you think about it, let's pose a hypothetical machine and we had infinite power, infinite threads and stuff, and we just ran in place. And we didn't do any of this stuff. We didn't write anything to a queue, then read from a queue, and use an orchestration framework. The trade-off is you're definitely, in some sense, using more CPU, more disk, more network, everything to run in this way. So you don't want this generically in tight inner loops that can fail altogether. But again, this is about a cloud pattern. This is about being cloudified. You're making sure that you can durably resume no matter what happens. And it turns out it adds very little overhead in the real term of thing. As the most typical path on the happy path is you write a control record, you write a job record. This is into a queue. The job record is read, the control record is updated. That is the happy path. And then, of course, the work is done. So it's a teeny bit of work, but it's important to note that those resources are literally right there, in the same, not only the same data center, but in the same stamp, the same collection of hardware. So it runs really damn fast.
Yeah. So if you compare that to, building out servers or even building virtual machines in Azure, you'd have to create some sort of distributed work engine or use,
exactly.
Something like a PBS Works or some sort of high throughput compute job scheduler to push work out and assemble the results back. So using a couple of functions, you can peel out a lot of data, pass it into worker functions that actually process each record, and then pass the results in their entirety back, and make use of cloud scale computing in Azure to be able to execute that on however many nodes are required to be able to, however much horsepower is required to be able to accommodate, the number of records you're processing.
It's also important to note that the company who I showed this to, they had a lot of dedicated compute in their solution, whereas this ran with million records very easily. It was like 30 or 35 minutes in our test, if I remember correctly. And it was using all consumption-based functions. So for those of you who don't know, functions runs in two models. Basically, you pre-allocate the hardware you're going to run on, and it's up 24 hours a day. You use it, you pay for it. Or there's the consumption model, which basically you're paying literally for the CPU seconds and the amount of network and storage you're using. It's very, 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 very little.
And how much do those cost when they're not running? So
zero.
Yeah, there you
Zero.
go.
Literally zero. And
Yeah.
and by the way, that's not even theoretical. That's a literal zero.
Right.
And there's
right.
another piece that I really like about the zero thing, and it's just the general comfort thing. I'm sure a lot of people about Azure are afraid of their spend. We're going to accidentally outspend ourselves. Well, it turns out you can do all the development for something like this locally, right? So it could be in the cloud when you're ready to productionize it. And by the way, on the other side, I always love to talk to DevOps. Maybe we'll have a chance at some future date to talk DevOps, but this really is amenable to being deployed, configured, tested, maintained through Azure DevOps too. It's ultimately just another form of an app service. So it has all the goodness of app services, the way you get managed instance security in without having to have people handle security minutia like certificate rotation. It has the same logging capabilities. It has the same monitoring capabilities. It has, quite frankly, the same security model, the same way that it's looked at from Azure Security Center. So I love that. I love functions, right? I could talk about them for hours.
Yeah, well, this is a really cool and powerful story. I think to me, sometimes it's with a feature like functions, it's challenging sometimes to take something is fairly abstract that requires code to make it work and execute or even be able to show it off.
Yeah.
And understand how can this bring value to me. So I think that taking something where you have large volumes of data coming in, and you need to process it really quickly and be able to report back whether or not that was successful or not. So really, it's easy to wrap your mind around, and
Yep.
and it's even easier when you kind of walk through how little code it actually takes to be able to do something that's fairly complex.
I think it is like the magic source. And I started off talking about I don't know how to do old style development any longer. And I think that is actually true. It is the vibe in the cloud is decompositional, right? It is basically, if you can break your larger problem into discrete pieces, and preferably if those pieces do not work in coordination except trivially with other things. In other words, if you can parallelize, if you can have a state engine style processing as opposed to one big gob of code in your old style app, then it's easier to debug. It's quite frankly, from my perspective, easier to conceive of and do, because you can take a piece at a time. You don't have to take the whole thing together. And then, of course, it's just cheaper and more performant.
All right. Well, thank you very much, Louis. Like I said, I think this really, to me, is a good example illustrating how you can take all these different, elements of, actually, it's really just using one capability of Azure, Azure Functions, but how you can assemble a number of these services together to be able to solve something fairly complex. And I think this, this hopefully solidified it for somebody else out there, maybe thinking about, how can this solve some problems that I might be encountering.
Cool.
Yep. Thanks, Louis. Really appreciate it.
Yep. And just once again, I'd encourage anyone who's interested in the thing going to dev.azure.com/Azure how to /funkydoodah. And if you're interested, I have a podcast on Azure, AzureAbility.com, or find it anywhere you find podcasts.
All right. Yeah, well, thank you very much. And looking forward to maybe having you on again, maybe talk about some DevOps stuff.
That'd be great. Thanks.
All right. Yeah, bye.